All right, so let's go through the proof of Euclid's Proposition number 16. Proposition number 16 says that in any triangle, if one of the sides be produced, the exterior angle is greater than either of the interior and opposite angles. And so what he's saying in that case is that if we kind of take this exterior angle over here, then any of the opposite interior angles, so this angle and this angle, are going to be smaller than that. And so if we want to look at this angle here, then that angle is guaranteed to be smaller than this exterior angle out here. So that's the content of the proposition. Let's see if we can prove it. Okay, so the first thing that we'll do is we go to this side BC and we want to find the midpoint for that thing. Okay, so we find this midpoint D, which actually gives us two congruent segments. It gives us that CD is going to be congruent to BD. Now what we want to do is draw the ray starting at point A and passing through D. So if we do that, now what we want to do is draw a circle centered at D, and we want it to pass through the point A. And so if I do that, let's draw the circle. Let's see what happens. We get our circle here, and that circle intersects the ray that we drew. And so let's say that circle is going to intersect that ray at point E. Okay. Now, because both of those line segments, line segment DE and line segment DA, are going to be radii of that circle, well, they've got to be the same distance. And so we've got this line segment congruent to this line segment. And that's pretty much all we need that circle for. So let's kind of get it out of the way so that it's not kind of cluttering things up. Now we can look at the third side of this line, of this triangle. Say we complete this triangle by drawing in edge EB. So if we put that in there, then one thing that we notice is our angles here are going to be vertical angles. And so by our vertical angles theorem, that angle has to be congruent to that angle. Okay, so what we've done now in this setup is that we've got this side of the triangle ADC congruent to this side of the triangle BDE. So we've got this side congruent to this side. We've got side AD congruent to side DE in this triangle, and that we've got the angles between them are congruent. And so by our side angle side axiom, our side angle side postulate for congruent triangles, then those two triangles have to be congruent. So our triangle ACD has to be congruent with our triangle BDE. Now, in particular, that tells us that the angle between the side with a single tick mark and no tick mark, so this angle has to be congruent then to the corresponding angle between the side of the other triangle that has one tick mark and no tick mark. So in particular, that's going to be our angle here. So we know that those two angles are going to be congruent. Now, for our exterior angle, so the important part of this is that with our exterior angle, that this small angle that we produced in our triangle BDE is going to be a part. So not a whole, not the whole part, but a part of our exterior angle. And so what Euclid's common notion number 5 then tells us is that the whole is going to be greater than the part. And because of that, our exterior angle is going to be smaller than the interior angle for triangle DE, DBE, and hence it's going to be our exterior angle is going to be bigger than our interior angle of our original triangle, ABC. And so this proves Euclid's proposition 16.